For your 3.6 notes, I would like you to have your Freddy worksheet beside you. Your Freddy worksheet is this worksheet where F stands for factor, R roots, A for asymptote. If you keep going, you have T is for the two, meaning it stands for tangent and together. E stands for end behavior, and Y is for your y-intercept. Have this next to you as you wash your notes. A function, or let's say a rational function, is always on the form p of x over q of x, where p of x and q of x are both polynomials. Here's the parent function graph. This graph f of x is equal to 1 over x. The function 1 over x goes to the point 1, 1 and goes to the point 1, negative 1. And if you want to graph it, it will look something like this. And also like this. As x approaches infinity, when it says as x approaches infinity, we're talking about x is going bigger and bigger and bigger. It's going to this side. As x approaches infinity, f of x, on the other hand, will approach 0. In other words, y will tend to get closer and closer to 0. The same thing will happen at negative infinity. Now, as x approaches, this time it says 0 with a plus as an exponent. It actually means it approaches 0 from the right, meaning this direction. It gets closer and closer to 0. As x approaches 0 from the right, f of x seems to be at infinity. And if you do the same thing this time from the left, it tends to go to negative infinity. X is equal to A is the vertical asymptote if, as x approaches A from the right or left, f of x would approach negative infinity or infinity, whether it's positive or negative. If it approaches one of them, then we have a vertical asymptote. We will have a horizontal asymptote, let's say at y equal b, if as x approaches plus or minus infinity, f of x will approach b. The end behavior, usually abbreviated as EB, is actually your horizontal and your vertical asymptote. They are the exact same thing. Finding asymptote. The very first and maybe the easiest one to find is the vertical asymptote. The vertical asymptote will be at x equal a, where a is a 0 of the denominator. In other words, the value that makes the denominator equal to 0 will form your vertical asymptote. Let's talk about horizontal asymptote. Horizontal asymptote, 3 scenarios will be presented. The first one is when the degree of the numerator is less than the degree of the denominator. In other words, I can give you something like x plus 1 over 2x squared minus 5x plus 3. This might be my function. As you notice, the degree on top is 1, the degree on the bottom is 2. If this is the case, it will have a horizontal asymptote at y equal 0, always. And looking back at your Freddy worksheet, all the way to the bottom, it says high over low is no. Low over high, 0 equals y. This is when you have the low power on top, the high power on the bottom, y equals 0 is your asymptote. Alright, if the degree of the numerator is now equal to the degree of the denominator, I'll take the example of 2. The degree of the numerator is equal. The degree on top here is 2, the degree on the bottom here is 2. When they're the same, y is equal to ratio of leading coefficient. The ratio of the leading coefficient. So let's go ahead and look at the 2 here. Where it says find all asymptote. I can tell already just by looking at it that I will have a horizontal asymptote at y equals, the leading coefficient on top is 3, the leading coefficient on the bottom is 2. If the degree, I'm going to 3 now, if the degree of the numerator is bigger than the degree of the denominator, then there is a slant asymptote. We will go into deeper detail about slant asymptote. All right, let's go ahead and finish with this. I have a horizontal asymptote at y equals 3 over 2. Do I have a vertical asymptote? The first thing to do is actually try to factor the bottom. Try to see if the bottom will give me some perfect factors. I have 2x squared plus 3x minus 2. To factor the bottom, I'll be looking for two numbers that the product will give me -4 and the sum will give me a +3. I would have 2x squared minus x minus 4x, actually plus 4x minus 2. Or I will have x times 2 minus 2x minus 1 plus 2 times 2x minus 1. So if I continue to solve this, I end up with 2x minus 1 and x plus 2. It seems like we have vertical asymptote at x equals 1/2 and at x equals -2. So we have a horizontal asymptote, we have a vertical asymptote. Now here's one thing. If you have a horizontal asymptote, it means that you have no slant. If you have a slant, it means you have no horizontal asymptote. It's either slant or vertical. Either slant or horizontal. When asked to graph a rational function, always follow Freddy. First factor, find the roots, the asymptote, identify multiples, and behavior and y-intercept. Let's go ahead and do the first one. I have 2x squared plus 7x minus 4. The first step is to factor. So f of x is the same thing as, once we factor this, you will end up with, on top, you will have 2x minus 1. And on the bottom, you will have actually x plus 4 also. On the bottom, you will have x plus 2 and x minus 1. The first thing you check for after you factor is the wholes. The wholes are determined by stuff that cancel from top and bottom. Here we have nothing that cancels, so I will say none. We don't have any hole. The next thing is the VA, vertical asymptote. To find the vertical asymptote, those are the value that cancel the bottom. So I will say it's x equal -2 and x equal +1. After this, I will find the horizontal asymptote or the slant asymptote. Here the coefficient or the degree are the same. The degree on top is 2, the degree on the bottom is 2. So we have a horizontal asymptote, and that's when we play that coefficient game. We will say y is equal to 2 over 1, which is 2. Now let's talk about the x-intercept and y-intercept. To find the x-intercept, you will set y is equal to 0. And if you set this equal to 0, it means that those are the values that cancel the top. So it will be at 1/2. That what makes the first parenthesis 0, 0. And the second one will be at -4, 0. The y-intercept would be the easiest thing to find. Is putting 0 for x. You will have 0, if you put 0 for x, this, and this will cancel. You're left with -4 over -2, which is 2. At this point, you can now graph. So I will go ahead and plug in the points. So I plugged in my y-intercept and my x-intercept. The next thing I will do is draw my vertical asymptote at x equal -2. I have a vertical asymptote, and I'm making it the dark, actually the green dotted line. I have an asymptote here. I also have another vertical asymptote at x equal 1. So I will draw another asymptote here. Usually we use dotted line for asymptote. I have a horizontal asymptote at 2, so I will also graph this here. Now, remember, asymptotes are end behaviors. So, can a graph cross an asymptote? Yes, as long as it's not at infinity. So, This one obviously tells me it's going to cross only once. It's not going to curve back to cross again. So it's going to come like this and go down. The next thing is I need to cross this pole. And if I cross this pole, it has this as an end behavior. So it will come like this. And the last portion, which is on this side, it doesn't cross the axis, so it must be above it. So it's going to be like this. Note that we're just sketching it. It's not accurate where it's crossing here. Let's study the next graph. I hope you understand this. The next graph, first step is to factor. So let's go ahead and factor the top. If I factor that on top, I will end up with x minus 5 and x plus 1. And on the bottom, I just have my x minus 3. First step is to find the holes. Apparently, I have none because there's nothing canceling on top and on the bottom. After that, I'm looking for my vertical asymptote. Vertical asymptote is at x equals 3. Would cancel the bottom. After this, since the degree on top is higher than the bottom, I have a slant asymptote. We will detail that slant asymptote in a minute. Let's talk about intercept. The x-intercept and the y-intercept. X-intercept would be those that cancel the top, and it will be at 5, 0 and at -1, 0. The y-intercept is plugging 0 for x, meaning I'm taking all the values within x. That will be at 0, 5/3. Let's go back and work on our slant asymptote. To find the slant asymptote, there are multiple ways of doing it, but I suggest that you always use the long division. So I will use the long division on this problem. So I have x squared minus 4x minus 5. And here I have x minus 3. If you apply the long division, you will need an x here. That will give you x squared minus 3x. You subtract or change all the sign. You end up with negative 4x. That will be negative x. Excuse me, minus 5. And you will subtract here 1 to get negative x plus 3. Change the sign. And you end up with -2. Honestly, what you end up with is not important. What is important is the value that you get here. That represents your slant asymptote. So let's go ahead and graph it. First thing I would do is graph my vertical asymptote. I do have a vertical asymptote at x equals 3. So x equals 3, I graph my vertical asymptote. I do not have an horizontal asymptote, but I do have a slant asymptote. So I would graph this line that has -1 as a y-intercept, meaning here, and I rise 1, run 1 here, and I would graph my slant asymptote as well. And that slant asymptote will look like this. Now that I have my slant asymptote and my horizontal asymptote, I will graph also my x-intercept and y-intercept. X-intercept is at 5, 0, meaning here, and at -1, 0, meaning here. The next one is my y-intercept is at 0, 5/3. 5/3 is somewhere, if I divide 5 by 3, it's about somewhere here. So let's go ahead and graph it. The location of your intercept kind of tell you the behavior of the graph. So it will come like this. Cross your y-intercept, cross the x-intercept, and use the slant as an asymptote. On this side, obviously, there might be something here, but if there's something here, this cannot be an x-intercept. So the only possible way of graphing this would be this. Nothing can be here because it will fail the VLT, and nothing can be here. It will again fail the vertical line test. Let's look at the next one. Once again, first step is to factor. So let's go ahead and see if we can factor this. To factor this, well, you need to be able to factor this number inside. Two numbers that the product gives you 3 and the sum gives you -3. I do not think you're going to find anything, so I'll leave it as it is. But I do know that I have no holes. Vertical asymptote, by the way, I'll go ahead and distribute this to make it easier since I cannot tell the degree on top. But if you distribute it, you will end up with x cubed minus 2x squared plus 3. Well, the power on top is higher, so by the way, the VA, we know the vertical asymptote is at x equal 2, and we will have a slant asymptote. We will divide it in a minute, but in the meantime, let's find the x-intercept and y-intercept, because that's pretty easy to find. Starting with the x-intercept, what makes the top equal to 0? Well, to find what makes the top equal to 0, since we know we cannot factor this, by the way, this is prime in real numbers, but you can factor it and get, or you can solve for it and get complex. But we're not doing complex. We cannot graph complex. So the only x-intercept I know is the point -1, 0. The y-intercept, on the other hand, is what makes actually canceling everything. In other words, I'll cancel the x cubed, the 2x squared. I'll be left with 3 over -2. So that will be at 0, comma, -3 over 2. Let's go ahead and solve for that y-intercept. So I have x cubed minus 2x squared plus 3, and on this side I will have x minus 2. So I will need an x squared times x, I'll be x cubed minus 2x squared. Once you subtract, everything cancel, you drop the 3. So remember, the remainder is pointless. All what we care about is this. So y equals x squared is my slant asymptote. I will start by plugging every single value, such as the x-intercept is at -1, 0, meaning here. The y-intercept is at 0, 1.5, meaning somewhere here. 0, -1.5, meaning here. My slant asymptote, I have a vertical asymptote at x equal 2, so that one is easy, somewhere here. I also have, I just graphed y equals 2, sorry. Say x equal 2, so it's somewhere here. This point does not exist. Sorry about that. So let's go back and plug in the point at -1 and a point here. The last thing to the graph is my x squared function. The x squared function looks like this. If we go through the point 1, 1, if we go through the point 2, 4, -1, 1, -2, 4, so it will be something like this. Again, this is just my x squared function. 4 should be at 16. This is the x squared function. And keep in mind, that's an asymptote. That's why I'm graphing with my dotted. I've been graphing all asymptote green. So from here, what I would do is, I know that this is an asymptote. So the graph of the behavior would be pretty interesting. If we come close to this, kind of mimic the x squared function and decrease to go to -infinity here. That's what happens on the left. On the right side, on the other hand, do we have any other, no, we don't have anything, any other x-intercept, so it has to be in between here. So it will go like this. How low does it go here? We cannot really tell. Once you get to calculus, you'll be able to tell that this is an x squared function and the blue one is the actual graph. All right, let's look at number 6, and I believe that's the last one. On number 6, I'll go a little bit faster, but this one has something special. The x plus 2. If I cross these two, that makes it a whole. So I have a whole at x equal negative 2. Well, it's not quite at x equal negative 2, but yes, x equal negative 2. But if you plug in negative 2 into the equation, what you will end up with, I have this. Once you remove negative the x plus 2 and you plug in negative 2, you have negative 2 minus 3 is negative 5 times negative 2 plus 5 is negative 2 plus 5 is 3 over negative 2 minus 1 is negative 3, which is 5. I plug in negative 2 because I crossed the negative 2. So the whole is at negative 2 comma 5. I also have a vertical asymptote, whatever cancel the bottom at x equal 1. I have the power on top seems to be bigger, because if you distribute this, you get a bigger one, a bigger power. Power of 3 on top, power of 2 on the bottom. So I know I have a slant asymptote. I'm going to let you work on the slant asymptote, but all you have to do is distribute this and divide by x minus 1. And you should get y equal x plus 3. Besides the slant asymptote, you also have an x-intercept at, the x-intercept is at 3, 0 and at negative 5, 0. And the y-intercept is at 0, 15. So I have a y-intercept here at 0, 15. I had an x-intercept at 3, 0 and at negative 5, 0. I have slant asymptotes at 3, 1. I have a slant asymptote at this level. I also have a vertical asymptote at 1. Wow. I have a vertical asymptote at 1. So at 1, I have also an asymptote. From here, I can easily graph, knowing that it goes through here. So if we cross it, go through this y-intercept, come closer, go through the x-intercept, and go till infinity. In between here, I should not have anything because I have another x-intercept. So if we come close to this, and also go down close to this.